Hello, it's a pleasure meeting you all in my mathematics class after a long time, and it gives me more pleasure because I'm handling the class from the United States. I hope that what I'm going to teach you will definitely help the students who are watching this, because the question that I'm going to discuss today is very important questions that is being repeatedly asked in Anna University, and invariably any book on random processes, particularly Markov process, you will find this problem. So you see that, let us now briefly I will go through what is called a random process. See, we know that what is a random variable? A random variable is denoted by x of s. This is called a random variable. It is nothing but x of s is the random variable which maps a sample space into a real space, that is real numbers. So a function, it is a function that maps the real space, the sample space into the real set of real numbers. Now, if this random variable is indexed by time, that is, if the mapping of such sample space into the real numbers happens in time, that is in what you call as indexed by time. It may be, the time may be discrete, that is it may be happening in a discrete time, or it may be happening in continuous time. So we call that particular x of s, we denote it by x of c. X of s is our random variable, and if it is indexed by time, then this particular set will be called as the random processes. Okay, so x of s is a random variable which is indexed by time, and this set x of st will be called as the random processes. See, it is called the random. I have discussed about these random processes in my earlier videos. You can just go through that and get a clear-cut picture of what is the meaning of a random processes, and I have discussed a few problems on that. Okay, now you see that this random processes, we talk about a Markov chain. See, we use this particular wording Markov chain in case if the random variable is dealt or indexed by time, which is time space is discrete. Time, that is countably finite or countably infinite. So you see that this t will, if random variable is discussed in time, which is either discrete, if it is discrete, we call it as a Markov chain, and you see that it can also be a continuous. Okay, now, so you see that, but here this Markov chain is a special concept that we deal in random processes. This Markov chain, particularly what it tells you is that, in simple words, the future depends on the present and not on the past. Let us suppose that this is our random process. Then I write something on the board. You just see that it is P of xn is equal to an. The meaning of is that, see, this, that is the random process x of n, which is at the state an at time n slash x n minus 1 a n minus 1 x n minus 2 is equal to a n minus 2 dot dot dot. If it is x naught is equal to a naught, that is, it is a conditional probability that p of, that is xn is equal to an, that is the random process can come to the state an when, after happening of all this, that is conditional probability. This can happen if only all these things happen. Can you understand? So you see that this is equal to, see, this is equal to P of xn is equal to an, and you have to take the immediate precedence, namely an minus 1. So you see that p of xn is equal to an slash xn minus 1 is equal to an minus 1. So the conditional probability of xn is equal to an, provided all these things happen, is nothing but p of n. See, this is equivalent. This p of xn is equal to an, provide which this depends on the immediate happening of the previous one, that is xn an minus 1. This is called your Markov process. So Markov process is simply tells you that the future depends on the present and not on this. See, these are all the past things that are happening. These are this an minus, all this an minus 1, an minus 2, an naught are called the states of the system. In the states of the system means the position it occupies at various times. So you see that this an minus 1 are all the states, and the random variable taking these positions, and this depends on not on all these things. It depends only on the immediate preceding one, namely xn minus 1 is equal to an minus 1. Such a process will be called as the Markov process. And as I told you, we call it as a process if time happens to be a continuous one. We call it as a Markov chain if the timings are discrete, that is, they are countably finite or countably infinite. So this is the meaning of a Markov chain. Now, these are all called the states, and we talk about what is called. Now let us come to the problem straight away. See, this problem is, what it tells you is that, so I have written the problem on the board. See, a gambler has rupees 2 with him. He bets one at a time, rupee 1 at a time, and the probability of winning is half. So this automatically, that means if I write this p of x, see p of winning is equal to half. So this implies p of losing is equal to 1 minus half, that is equal to half. That means the probability of winning or losing has equal chances, half and half. Then another thing that is given is he stops playing if he loses rupees 2 or wins rupees 4. That means he plays with 2 rupees. If he loses all his money that he has, maybe 2 rupees, then he stops playing. And if he wins 4 rupees on the whole, that is, he has got 2 rupees with him. If he is able to win 4 rupees, 4 plus 2, 6 rupees, when it comes to 6 rupees, he quits the game. So in both the cases, he quits the game. When that is so, the question is, what is the relative Markov chain? That means transition probability matrix. We call it as transition probability. I will explain this now. So he said, next question is, what is the probability that he loses his money at the end of 5th round? So here, let us now discuss this problem. See, I will write it here. See, what we want is, I will just write this. See, I will put somewhere something like this. See, I will call this a transition probability matrix. It is called a transition probability matrix. It merely tells you, I will write something and explain to you. 0, 1, 2, 3, 4, 5, 6. This is 0, 1, 2, 3, 4, 5, 6. Now you see that this is the amount, that is xn minus 1. This is xn. Now you see that, see, xn minus this xn, I will write it here. See, let xn be equal to 0, 1, 2, 3, 4 and 5 and 6. This means xn is the amount of money. Xn here, I just mean that it is a random variable. It's a random variable. Xn is the amount of money he has at the end of n rounds. See how many rounds are there? At the maximum he can go up to, say, that is 5 rounds. The sixth round he is off. Sixth round he is off. So you see that here xn refers to the amount of money he has at the end of n rounds. Now it is given that now here what I am going to do is the probability transition matrix merely tells you what is the probability of getting 0 or 1 or 2 or 3 or 4 or 5 or 6. He has given in the problem that he bets, he has got 2 rupees and he goes for a betting. He has 2 rupees and he goes for a betting. That means the initial probability, what is that? I will write it as P naught. This is the initial probability. The initial probability is that he does not 0, he does not. That is the probability of having 0 is 0. That means 0 is 0 money, I mean. And the probability of having 1 rupee is, the probability is 0 because he has got 2 rupees with him. Now next is, you see that next one is 1, then, so this is the initial probability. This is your initial probability. Initial probability in the sense the probability with which he is going to bet in the game. See, he has got 0, 0 means 0 rupees, he does not bet because he is having 2 rupees with him. So he is going to challenge in gambling with the probability 1 with an amount he has. What is the amount he has? 1 rupee, 2 rupees. So 2 rupees he has got. Now with that amount he is going to challenge in the gambling, and the chances of challenging the gambling is probability 1. That is, here I have put as 1. So this is called your initial probability, and this is the, here see the amount, this is a xn is the random variable of having the amount at the end of nth round. So this is xn refers to what? The amount, the random variable of the amount he is having at the end of the nth round. And P naught is nothing but the initial probability. Now I am going to prepare what is called your transition probability matrix. Now let us come to this. Now you take this. Now if he is having 0, if he is having 0 amount, it means that he has to necessarily quit. That means he will not take part in the game. That means there is one probability. See, understand that it is transition probability matrix. That means this matrix consists of elements which are nothing but the probabilities, and the probability at the maximum 1 and at the least 0. It cannot be a negative quantity. Now if he is having 0, it means that what? He will not take definite, and the probability was 1 that he will not challenge in the game. That means it is 1, 0, 0, 0, 0, 0, 0, 3, 6. Okay. Now that means what? If that is xn minus 1, this is the amount that he has. That means what? Here I will come to this. See xn minus. Now let us suppose that he is having, that means if he has got 1 rupee, then there is a probability that, equal probability that it will be half, and it is the probability of, see, the probability of winning is half and the probability of losing is also half, and the rest of the place is 0. So you see that. So if it is xn minus 1, if it is 0, then the probability of xn will be what? 1 will be half and 2 will be half. If he wins, half a chance. If he loses also, half a chance. So if he wins by half a chance, he will be getting 2 rupees. So he can go for further play. But if he loses means he gets 0. If he loses means what? He is losing his money that he has to give up, and therefore you see that he will not be in a position to continue the game. Okay. Now, so this is one way. Now let us come to 2 rupees. Now when it is 2 rupees, he has got half a chance of winning and the rest of the places are zeros. Rest of the places. And if it is 3, he has got half a chance of getting to 2 rupees and half a chance of getting to 4 rupees. If he is getting 4 rupees, he can continue playing. If he is getting 2 rupees also, he can continue playing. But if he is going to slip down to 0, he said that he will not be able to play. So this is, now this is 0, this is. Coming to 4, this is half a chance, and 0, 0, 0, 0. And if it is 5, it is 0, half a chance, and it is say 4, 3, 2, 1, 0. And if it is, you yourself can tell me what will happen if he comes to 6. So what will happen if he comes to 6? So it means that he is getting the 6 rupees, and that 6 rupees will tell you that he has to stop playing, because as per the problem, he will stop playing if he gets into 6, and he will also go, he will stop playing if he is getting, that is, if he ends up with no money inside. That is, I'm sorry, this is like this. This is like this. So this is a transition probability matrix. I will explain once. So you see that if you suppose that the person is having 2 rupees, he has got half a chance of winning, losing, half a chance of winning. And therefore he can further play, and here also he can further play. But you see that if he comes to 1, and if he is going to lose half a chance and end up half a chance, he will end up with 0 and he ends. That is, he will stop playing the game. And likewise, if he continues with that, he goes on, there is a winning spree for the person, and he goes on winning. You see that at the maximum he can get 4 rupees maximum profit, and with that profit plus 6 rupees he makes, and he stops playing. That means these 2 states are called, state 0 and state 6 are called absorbing states. They are called absorbing states in the sense that further movement from 0 to 1, 2 or 3 are not possible, and coming back from 6 to or going further is not possible. So these are called absorbing states where it ends. That is, it cannot escape from that 0 or 1. So these are called. So this is your transition probability matrix. Now, you see that this P naught is given to be the initial probability. If initial probability and the transition probabilities are known, then we can very well answer the questions as this. What is the probability that he loses his money or he gains money? You can ask in any way. But in this problem you are asked, what is the probability that he loses his money at the end of 5th round? You can go for 4th round or 5th round or whatever it be. So that is, how do you find? That is, the answer for this question is, say it is like this. I will call this as if, see, this is your initial probability. So your first probability of, this is your first probability. That means what? That is, initial probability is that. Then what is the next first probability of the game? What is the probability of the various states in the game? That is, P1 is given by, it is P0 into A. This is what you will get. And if you are going to ask for the second round, this is the first round probability, of various states, and this P2 is the second round probability of various states. This is nothing but what? Your P1 of A, that is nothing but P1 of A means what it is? P0 of A into A, that is equal to P0 of A square. And what is your P cube? P cube is what? It is P squared into A, that is equal to it is P1 of A into A, that is equal to what? It is P0 of A into A, that is equal to P0 of A cube. Likewise, if you go, it is P0 P to the power of n, that is after nth round of the nth round, this is nothing but P0 of A to the power of n. So you see that this is how we calculate the probability of various states. The various states means the amount that he is likely to have after 5th round or 4th round, something like that. Okay, so you see that this is how we find. Now what is our job? Now since he is asking you to find what is the probability that, what is the probability that he loses his money at the end of 5th round. That means what is that 5th round? So P5, what is that is? P5 is equal to your P0 into, it is P0 into, it is 8 to the power of 5. So this is what you will get. So this is what you get. Now we have if I am able to find this, you see that my problem is over. So this is what I am going to do. P1 is equal to P0 into A. P0 into A will be nothing but what? Your 0, 0, 1, then 4 zeros like this. A into the matrix like this. What is the matrix that you are having? 1, 7. Then it is half, 0, half, 0, 0, 0. Then it is 2 means 0, half, half. Then it is 3 means 0, half, half. Then it is 1, 1, 0, 2, 3, 4, 5, 6, 0, 1, 2, 3, 4, then 5, then 6. So this is my matrix A. So A is our transition probability matrix. Now if you multiply this first row into first column, you will find that first row into first column is 0. Then second row into first column is again 0 into this is 0, 0, 0. This is half. See, 0 into this is 0, 0 into this is 0, this is half. Then you get, then you get this to be, see, it's the third one. Here if you take the third one 0, this is 0, everything is 0. And this is 0. Okay. So this is what you get. So 0, half, 3, 0. So this is your P1 of E. This is your P1 is nothing but, that means at the end of second round, the probability of the gambler to have half a chance to have rupee 1 and half a chance to have rupees 3. This is the meaning of that. What is the meaning of this? At the end of round 1, the gambler is, there is a possibility of the gambler to have 50% chances to have 1 rupee and 50% chances of having 3 rupees. So this is the meaning of that. So when you go for this P2, P2 is nothing. What is your P2 now? P2 is nothing but P1 of A. P1 of A is nothing but what? Your P1 of A is P0 of A into A, that is equal to P0 of A square. So if you do the multiplication P1 of A, P1 of A is nothing but P0 of A square. P0 of A square, you will have to go for the multiplication of this again with this and then multiply with P0, then you get this. Then your P3 will be equal to, again this is nothing but what? P2 of A, but P2 of A is equal to A P0 into A square into A, that is equal to P0 of A cube. How we are getting this? So like this if you go, then your P4 will be that. So you see that this is the The first probability, the initial probability is, we know very well. What is that? This is the initial probability. And the transition probability matrix is known to us. The first probability, that means what? The first probability of the various states. See, these are all the states. The first probability of various states is obtained by multiplying P naught into A. A is nothing but the transition probability. When you do the multiplication, this is row into column, row into column, row into column. If you do that multiplication, you see that 0, half, 0, half you get. This means that probability of having, at the end of the first round, the probability of having rupee 1 is 0 is 0. Probability of having 1 is half a chance, and the probability of having 3 rupees is half a chance. The rest of them are zeros. If you go for the second probability, that is, at the end of the second round, what is the probability? What are the probabilities of the states? Okay, what is the probability that you may have 0 or 1 or 2 or 3 or 4 or 5 or 6? Now, how do you calculate? P square is equal to, this means what? The probability of the second round of the states. P2 P square is equal to P1A, P1A, P1. See, we have got P1 into A. That is nothing but what? P1 here, but P1 is nothing but what? P naught of A. So P naught of A into A, which is nothing but P naught of A square. Now, this has to be, A has to be multiplied by itself. And you do the multiplication with the initial probability. How do you get this means? See, this extreme, don't bother about that. This you retain it as it is, 1 by 4, 1 by 4. Then use, while dividing this by 2, so you get it as what? 1 by 4. So 1 by 4 you add on the left hand side, 1 by 4 on the right hand side. This 1 by 4, if you are going to here, okay, coming to this, 0 means this, you divide this half by 2, you will get 1 by 4. Add to the left, it is 1 by 4. Add to the right, 1 by 4. And here this 1 by 2, if you are going to divide it by 2, 1 by 4. So here 1 by 4 plus 1 by 4, it is half. And you shift this half 1 by 4 to this side. So it is 1 by 4, 0, 0. So you see that the new probability, that is P square, will be equal to 1 by 4, 0, half, 0, 1 by 4. 0. That means the probability of having 0 rupees is 1 by 4. Probability of having 2 rupees is half. And the probability of having the 0, 1, 2, 3, 4 rupees. 4 rupees is 1 by 4. Now, how to get the third probability, third round probability of the states? How do you do that? See, this 1 by 4 extremes don't bother about, don't disturb. Multiply, divided this by 2. So 1 by 4 plus 1 by 4. You add on the left hand side, 0 plus 1 by 4 is 1 by 4. And this 1 by 4, you have to add it here. If you are going to divide this by half, it is 1 by A. 1 by A plus 1 by 4 you will add. So you get 3 by A. And this goes to 1 by 8, you will add on the right hand side. So this is 1 by 8 and 0. Now what does this mean? At the end of the third round, the probability of having 0 is 1 by 4, 1 is 1 by 4, 2 is 0, 3 is 3 by 8, 4 is 0, 5 is 1 by 8, and fifth, having 6 rupees is 0. Coming to the fourth, in the same way you have to do. Coming to the fifth one, you see that you are getting this. Here also you see that this is 3 by 8, this is 0, divided this by 2, that is 5 by 32, add on the left, it is 5 by 32, so you are getting 5 by 32, 5 by 32, add on the right hand side, this is 1 by 8, 1 by 8 plus 5 by 32, you will get it as 9 by 32, and here again you see that this is 1 by 4, and you get it is 1 by 8, and you get it is 1 by 8 is here, 1 by 16 is retained as it is. Now you see that means if you really go for a multiplication of the transition probability matrix and again multiply it by this P naught, you will end up with these values only. So what does this mean? This P1. This means probability, and this is the first one. This P5 is the probability of states at the end of fifth round. Now, What is, now you read yourself, you will get the answer. What is it? What does it mean? 3 by 8 chances. What is the meaning of that? This refers to 0 state. This refers to first state, second state, third state, fourth state, fifth state. That means the probability of having 0 rupees at the end of fifth round, probability of having 1 rupee at the end of fifth round, probability of having 2 rupees at the end of fifth round, likewise it goes on. Now what is it from this? What is the question that is asked? What is the probability that he will end up, that is he will stop playing. That is he will stop playing means what? Without money here. Not that he is getting the 4 rupees plus 260 he is not getting, but at the end of fifth round, what is the probability that he goes out of the game without any money to challenge in the game? That means what? 3 by 8 chances. So there are 3 by 8 chances that he will quit the game because he doesn't have money to play with. Okay, and like this you can answer the answer. See, what is the chance that, what is the probability that at the end of the fifth round he will quit the game having won 6 rupees? That means 4 rupees he has won. So he is having 6 rupees. Now having won 4 rupees, that means 1 by 16 chances that he will quit the game having won 4 rupees. And here it is the 3 by 8 plus chances probability that he will quit the game because he doesn't have money to play with. So this is it. So the answer is he will stop. That is the probability that he will quit the game losing the money, losing all his money is 3 by 8. So you see that this is the answer for the second question, and that is the probability diagram I can give you like this. That is the state diagrams. This is 0, 1, 2, 3, 4, 5, 6. Now you see that if he is adding 0, 0 to 0 is a what? This is an absorbing state. Then 0 to, see, if he is adding 1, he can go up to what? Half a chance that he will win, half a chance that he will lose. So if he loses, he comes back, he comes to 0, and that this is the 0 means he will come back to he will come to 0 and he will not further play. So this is called your absorbing state. This is called your absorbing state. And he goes to play this one. Now 2, he can go for playing again. So this is like this. If he loses, he comes back to this. So, okay. So, comes back like this. And 2 to 3, and he can, if he loses, he comes to this. And goes like this. He goes like this. And he comes back like this. And if he wins, he goes to like this, and he will not play at all. So here the chance is 1, and here the chance is 1, but here all other places the chances, this is the state diagram of this, and that here these two are called the absorbing states. Here this is 0 and 1 are also called, see, this 1, 2, 3, 4, 5 are called the recurring states, because 1 to 2 is possible, 2 to 1 is possible. If he wins, he can go to 2. Likewise, these are possible, whereas this 1 and 0, 6 and 1, 0 are nothing but your absorbing states, for the simple reason that they will not further play after getting into 0 or getting into 6. So these are the small aspects that I have told you. I will teach you more on this states of the system in my coming classes.